Welcome, everyone. My name is Rachel Portinga. I am a PhD candidate of health sciences at Lakehead University, and I'm also the coordinator for the Lake Superior Living Labs Network, or the LSLLN, who is hosting the meeting today. So just really briefly, the Lake Superior Living Labs Network was started in 2018 as a platform to connect academics and community groups with the overall purpose to develop and expand partnerships and collaborative initiatives that are rooted in sustainability and social justice across the Lake Superior watershed. The LSLLN functions at the watershed scale and has hubs in Thunder Bay and Sault Ste. Marie, Ontario, along with Houghton, Michigan, and Duluth, Minnesota. Today's event is intended to support those LSLLN goals of connecting people across the watershed. So we're so happy to see people here from a broad range of sectors, disciplines, geographic places. I would also like to thank the sponsors of today's event, the Remedial Action Plan, some of you may know that as RAP, Lakehead University, and the Lakehead University Year of Climate Action. My role today specifically is to provide technical support. So if you have any questions related to tech, chat, anything like that, please send me a direct chat using Zoom, and I'd be happy to answer those for you. And as I think you've all been notified as you come in, the event today is being recorded and will be shared later on the Lake Superior Living Labs Network website. So feel free to turn your video on or off as you feel comfortable, knowing that this is being recorded. And we also have the live transcript enabled at the bottom for accessibility. I invite you now in the chat, if you'd like to share your name, your pronouns, the place from which you're joining us, and any affiliations by way of introduction, so we can start to see who's here in the meeting. And with that information, Rob, I'll turn it over to you.
Great. Thanks, Rachel. My name is Robert Stewart. I'm an associate professor in the Department of Geography and the Environment here at Lakehead University on the North Shore of Lake Superior. It's really exciting to see well, first of all, the registration and the people that are here, some people from overseas, which I think is exciting, and faculty that are overseas. The intention of today is to present, relevant immediate data that is being collected on an ongoing basis and shows recent changes. And really the idea is to extend just beyond looking at long-term changes and ramifications and impacts, and to start to recognize these changes in the Lake Superior that are happening now, and not just to look at impacts, but to further understand the mechanics and the feedback loops of changes on the lake. To date, we look at things like ice cover and water temperature and lake levels, which are all critical, but there's much more processes and mechanics in the lake that open our minds to the consequences of a changing lake so that we could be more adaptive. So it's in the spirit of presenting relevant recent data and then thinking through as a group, how we address that type of information, what more research can we do, or what actions can we take to recognize these changes. So that's the intent of the group of the meeting today, in the sense of the presentation. And of course, the network that most of us are a part of helps to share and spread that information and link groups. Of course, before we begin, I would like to acknowledge the land that we are on, and to give that recognition to the land that we share, and the gifts that we've received from those people that have come before us. We recognize that we are living and working on the traditional land of the Anishinaabe people, signatory to the Robinson Superior and Robinson Huron treaties of 1850, signatories to the 1836, 1842, and 1854 treaties in the United States. We also acknowledge the political representatives of Indigenous nations in Northern Ontario, the Anishinaabe Nation, Grand Council Treaty Number 3, Anishinaabe, Aski Nation, and independent First Nations across the basin. In our work with the Lake Superior Living Labs Network, we aim to protect the land, water, and beings in the Lake Superior Gitchigami watershed. We also acknowledge the original custodians of this land who have protected the water, land, and beings for time immemorial, despite ongoing efforts to displace and disconnect them. We aim to support their work by building and continuing relationships with the Indigenous people around Gitchigami based on the principles of mutual trust, respect, reciprocity, and collaboration in the spirit of reconciliation. We're all treaty people. And with that recognition, I would like to introduce you to our speaker today. Graham's background, Graham Saunders, who lives in Thunder Bay and works at Lakehead University as a lecturer. He has a significant background, including employment in the meteorology with Australian Weather Bureau. He's worked for Environment Canada and fire weather forecasting at large project fires for the Ontario Ministry of Natural Resources. He's taught various energy, weather, climate-related courses at Lakehead University since 1995. He is continually doing research and writing on his own weather observations, weather stations, and local newspaper input as contributions. And Graham is one of those people that truly is interested and has purpose in looking at climate and climate change and having an impact and a voice in our community for awareness and education. And so it's really exciting to have a speaker that has, obviously an academic experience, but has such a deep personal connection to the data as well, and interest in the data and real meteorological data, not just modeling and predictions of climate change. So with that, I would like to, without further introducing the context anymore, Graham's research again is really the benefit of this is when you have someone looking at the data day after day and week after week, the changes that occur can be seen immediately, and sharing that early is really the intention here, in the spirit of helping him maybe make sense of it and talk about ramifications or recommendations from this type of data. So we'll have a chance after Graham presents to discuss and ask questions, and maybe even move into some form of dialogue around the implications of this and how we move forward with these current understandings. So without further ado, I'm going to ask Graham to maybe pull up his presentation. It is made for a general audience, so I hope that people can appreciate we have so many actors in Lake Superior on this call, not just scientists or climatologists. So the idea is to focus on the data and take our time going through that, but to bring it out to a larger rounded audience than just maybe the community that Graham works with his research. So again, without further ado, Graham, if you want to start your presentation, make sure you're off mute and all those things. And if everybody else is making sure they're on mute, and any other distractions can be avoided. So I see your presentation there, Graham, and once you want to put it into presentation mode, I'll let you begin. So it looks like
Thanks very much, Rob.
Good to me. Yep. And there you go.
Okay. And I presume you can hear me okay?
Yep. Great.
Well, thanks for the introduction, Rob. And you have your stories to tell, but we won't deal with those today. Rob just got off Lake Superior after a week on the Big Lake. And so he knows some of the character of Lake Superior. I'll remind people, everybody knows this, but 10% of the fresh water in the world is just out on our doorstep out there. And another, we don't have time for all the characteristics and myths about Lake Superior, but one is that it's a weather maker, and I think everybody knows that. And another fascination I find is that some of the effects on Lake Superior have origins thousands of kilometers away. And that's the weather person in me talking about that. I spend a lot of time on Lake Superior and next to it, kayaking and so on. And for years, I've kept spreadsheets of various things going on Lake Superior, the temperatures, the water levels, precipitation in Thunder Bay and around the lake, and looked for what's happening with trends and sometimes the magnitude of the changes on Lake Superior. So today's talk, I'll be talking about mostly the 21st century, and I'll compare that a little bit from time to time with the previous century and compare and contrast. So a few highlights of my talk will be what is new in 2021 and also a little bit into this year. And I'll mention the a really notable delay in the fall overturn last year. And also I'll mention that we've had a major 2 or 3 year decline in water levels in Lake Superior. And I think most people know that over time, the lake has become warmer. We have less ice cover. And one of the big features I've noticed is that we have a lot more variability in different factors on Lake Superior or next to Lake Superior. Things like ice cover have changed and are much more variable. Most of the data I'm using is from NOAA. And I'm going from the years 1995 to 2022, pretty much. And as I said, I'll talk about a few different aspects that are obviously different from the last century. Okay, here's your cram session. I'm going to use a few terms like overturns and stratification. And this is a review of what this means. One of the things I could have tempted to call this talk is the wonders of water, because I think everybody knows that water can be in liquid, it can be in a gas or a solid like ice and snow. But there's another major feature that we really don't see, and that's density. And that's a huge factor in all of the things that I've listed in the, put little notes on about above. And overturn, stratification, all are very dependent on the density of water. Again, we don't see that most of the time unless it becomes ice, and that it's pretty visible then. So I'm going to talk about this slide quite a bit. And Rob, I think a couple of weeks ago, I mentioned this slide could be pretty busy, take a long time to explain. And Rob remarked that sometimes he has slides that could take an hour of a presentation. Well, I'm not going to do that today, I hope. But I want to walk you through what happened last year as an example of what happened last year, but also what normally happens on Lake Superior. So on the left-hand side, the y-axis, I have temperatures on the lake, and on the bottom, on the x-axis, we have time. And that will be, a lot of the slides I'll show will have that feature of temperature and date at the bottom. And I hope I'll remember to tell you when it's not the case, but you'll probably notice that anyway. So let's go back in time to early January last year, not 2 years ago. The black line that goes through this figure is 1921. 2021. And the red line comparison with another year, and the green line at the bottom here is it happens to be one of the coldest years on record on Lake Superior, 1996. So back to early January, 2 Januaries ago, the black line is relatively warm. It's just a little below 4 degrees. And in the previous slide, I mentioned how critical this temperature of 4 degrees is. Water is most dense at this point. And as we go through the next month or two, we see the temperature, day-to-day temperatures are declining. And we get into February, into March, and we have this to me, it's a remarkable confinement of all these temperatures of all these years. There's 28 of them, and they're all within a couple of points above 0 to 2 degrees all the time through this whole period here. As we know and expect every year, eventually the beginnings of spring come and the temperatures start to rise. And again, we're on our black line here, and we go through warming temperatures in April and into May. And this is when we have our spring overturn take place. The temperature rises above 4 degrees somewhere in May. And then after that, we have what's termed the beginning of summer stratification. Now, that's been a change over time. If we go back to the 20th century, in summer is delayed into June, somewhere the first week of June or even later sometimes. In more recent years, in the 21st century, and earlier as we proceed, the spring overturn and followed by the stratification happens in May, usually later in May. And after that happens, we see much more spread in the temperatures in this particular figure. We go from a couple of degrees of separation, and as the lake warms up, later into spring, into the summer, we have much more of a spread. This is 28 years, so I guess we expect some kind of variation, but we see that the 2 degrees spread here becomes into July and August. So in the typical year, all years really, most of our variation in temperature, maximum of the year, is happening in the summertime. If we march a little further, not surprisingly, late August into September, we have a cooling trend in the lake. Water surface temperatures get cooler as we proceed. Here's one of the things that caught my attention last year. So it's September, and the lake temperature is declining as we expect. And then suddenly, at this point, I hope you can see my cursor here, the temperature doesn't decline anymore. It starts to rise again. I checked the records, and I wasn't able to find anything like this before. So late in September, and then persisting through into the middle October, we have the temperature rising or starting to fall again, but way above the long-term normals for October. And I remember last year seeing people swimming in Batchewana Bay near Sault Ste. Marie in the middle of October. Phenomenal. Everybody knows some of the myths about Lake Superior. It never warms more than 4 degrees. That's not true. But here was an example of the water temperatures being 14, 15 degrees in October last year. After that, the temperature did decline, and you can see it. It's most of the time it's in record territory for a couple of months as it declines. And then as we get a little later in the year, getting into November, we can see that it's starting to mix with old temperatures of the lake, the old averages. And it was a toss-up whether it would be a fall overturn in the calendar year or not. You see the year ended up at this point here is a little bit above 4 up, whether we had overturn on the final day of this last year or it persisted into January. So let's look at what's happened with some of the seasons over time. Oh, I'm sorry. I have a little animation back in here to give you an update on where we are now. We started off the year at 4 degrees, which is in record territory. But I think anybody living around the lake recalls that we had some really extreme cold temperatures end of December and beginning in going into January, February, and March. And we had the temperature, the surface temperature of Lake Superior began at 4 degrees. And after some weeks, it was below the long-term average. So we went from one extreme down to, if we get into middle March, almost as cold as it gets, that a little bit above zero in the lake. And then you can see the trace highlighted in yellow here. This is taking us through the usually cold months of January, February, March, and into April. But nevertheless, once we got into May, we had a warming trend again, and the lake, the ice was fairly thin and broke up fairly quickly. I'll get back to that a little later in another slide. But we had a warming trend, and it looked like it was going to get up to a typical temperature in May, and then the last few days have been fairly cold, so that little trend ended. So we'll go to what's happening with various seasons. And I think I'll start. Again, the temperatures are on the y-axis and time at the bottom of the figure here. I think I'll deal with fall time because we were just talking about it. So the trend is to more and more warm weather in October and higher temperatures. So the long-term trend, if we go back to the late 20th century, is that the average temperature of the fall season, and I'll explain the way of depicting seasons is a little different from what you're used to. October, November, and December are the fall season in this case. It's based on the warmest and the coldest seasons for Lake Superior. Most of the time we deal with air temperatures, and if we're going to talk about winter, we'll talk about December, January, and February. But in this convention, we shifted ahead of time. As you all know, Lake Superior has a massive amount of water in it. The volume is considerable, and there's a lag time of the coldest air temperatures or the warmest by at least a month over what happens with air temperatures. So back to October as our sample season. The long-term trend takes just above 6 degrees, and it warms more than 1 degree over our period up to last year. You can see there's some variability in this. We have last year was the warmest fall on record, and there's ups and downs all along all of these traces. This is it's rising according to these numbers, 95 to 2021. It's rising by about 0.4 of a degrees per decade. So we have considerable rise, and also it's significantly significant. Other seasons, all of them are rising in temperature over these almost 2 decades, 3 decades, but fall time is the only one with statistical significance. If we go to the top, we notice that, yes, warmer summers, water temperatures in Lake Superior, but there's much more variation from summer to summer, as we saw in the last figure. changes. The convention on the y-axis has changed a little bit. It's now on the bottom of the figure. So if we look at springtime, on the left-hand side, we have the day of the year. This is the convention. Day 1 is January 1st, and then we go through 365 days for the year. And I'll just take a glance at springtime to give you an idea of some of the change in stratification, the overturn, and then the stratification that follows. In the old days, in the 20th century, typically this happened on day 150, which is about in early May. In early June. And then over time, the date of reaching 4 degrees has changed. It's become earlier in the year, and you can see the trend line there from left to right. It amounts to about 5 days per decade, so a fair number of days overall. Moving up to what's happened with summer stratification, signified by the red line here, we see that it starts off fairly limited, but over time we have longer and longer amounts of time with summer stratification. The temperature is at 4 degrees or warmer. So we can see a pronounced rise in summer stratification, about 9 days per decade. And at the top, we have the fall overturn, and that begins in early December and progresses from then on. I have a blow up or stretching of the time here so we can see this a little more clearly. We could see last year it happened probably on the final day of the year, day 365, but looking at this gives us a blow up of that. So in the old days, it used to happen in early December, and now it happens much later in the year, and it averages about 4 days per decade. So what that means, one of the things is that I have taught this overturn process, as I think everybody knows, is very vital for Lake Superior and all mid-latitude lakes. And I'll have my fish do a little talking here. The spring overturn is especially important because it initiates the season, but also distributes oxygen, nutrients throughout the water column. So this changeover, the turn over the lake from the lower depths to the upper, mixes, as I said, oxygen and nutrients throughout the column. So different fish and other species can feed at comfortable temperatures. For lake trout, this is often 10 degrees to 15 degrees Celsius. It also mixes water in circulation, and it refreshes near shore water quality. So if we have stagnant water pollution, it will tend to shift this away from the near shore. So I want you to imagine this cross-section as Lake Superior. And we're talking about the spring warming and overturn. And imagine on the left-hand side here, we're on the western shore of Lake Superior, Duluth, Thunder Bay, that area here. Or on the east side, Batchewana, Whitefish Bay, and also southern shores of Lake Superior. The process in the springtime is initiated by shallow water warming, and you can see the circulation here. And so it starts off below 4 degrees, but with time it becomes warmer. And this thermal bar of 4 degrees moves out from the shoreline. This is true from the west shore, but also the south and the east shore of Lake Superior. So eventually, the water temperature, the average temperature on Lake Superior is 4 degrees throughout the lake. Obviously, it happens different times and different places, and the timing is different, but eventually the lake is an average temperature of 4 degrees. And this signifies stratification of the lake, the beginning of summer stratification. And I'm going to skip over a few months and go to what happens in the fall time with the overturn. And 2 examples here from last year. The graph indicates temperatures. Blue, dark blue temperatures are below 4 degrees, and you can see that we have some cooling to that extent. This is the winter solstice, and we have cooling in Black Bay, Thunder Bay parts, and some of the bays around the lake. We have the cool temperature down below 4 degrees. Still not ice covered yet, but it's colder than that. The other temperatures, the extent of red you see is blue are temperatures. Typically in December at this time, they're not going to be much above 4 degrees, but they are warmer than 4 degrees in the upper figure here. If we go back further in time last year to a couple of days before the end of the year, we can see much more of the lake is at 4 degrees. We have a little more temperatures below 4 degrees and a shrinking amount of light blue or above 4 degrees. And we see this at the eastern end of the lake. As you know, the lake is deepest at this place in the eastern part, and the mixing that has happened and descent of warmer temperatures in the summertime has warmed up this massive volume, and in the fall time, it's slower to cool. By the almost the end of December, more than half of the lake is cooled down to 4 degrees. Winter stratification period begins. And this is a sample. I mentioned that the density of water is so important in those processes we just looked at, as well as ice formation, because ice can't form till the fall overturn takes place and the water cools more than that. And certainly ice is visible. The density of ice is about 90% of fresh water at 4 degrees. So we can see this is just a flashback to another year. It's a relatively high water temperature year for Lake Superior. It's 2016, and it's February 15th. So we can see ice is still in the bays on the North Shore, and most of the South Shore has ice coverage as well. The rest of the lake has got up to above melting, and most of the ice at this particular example of a few years ago, day 46, is open water. So let's look at the long-term record of ice coverage on Lake Superior. The timing is a little different on this one. We're going back to 1973 to 2020. And on the y-axis, we have percentage of ice cover. So we look at this, and this is the maximum temperature, the amount of ice in any particular year. We can see a lot of variation. But if we look at the two periods of time here, 1973 to 97 or so, that's about 25 years, we can see that often in the past, the 20th century, we have a lot of ice coverage. Occasionally we have less coverage, but it's not a lot of variability if we compare to the most recent 2.5 decades, where we have, yes, we can have lots of ice coverage, but there's many years, and sometimes one after the other, alternating between a lot of coverage and very little coverage. Overall, if we look at these about 50 years, the ice coverage on Lake Superior has declined over time. Lots of variation, but it's about 7% per decade. And translating that into maybe an understandable term, if you know approximately the area of Thunder Bay in square kilometers, it's about 1 Thunder Bay a year. So briefly to talk about what happens if we have less over time ice on coverage on the lake. We have more evaporation and more access for bright sunlight, and typically warmer temperatures, and always a factor in breakup of ice on Lake Superior are wind and other weather. This year, 2022, is somewhat of an anomaly because we started off with almost record low ice coverage, and then we spiked up to very briefly to 80%, but it was very thin ice and disappeared fairly quickly. The red year is a very ice intense year, 2014. This is in comparison to that. Quick look at water levels in Lake Superior. This is 2007, and in this particular year, there were a lot. You can see that there's sign bars there, and the concern was that we had 10 years of declining water levels, and you can see the result in 2007, and it was one of the scenarios, what dire consequences if we have this continued drop in lake levels. Didn't happen. And here's a glance at water levels over a 100-year period. So you can see there's ups and downs, and there's much more variability when we get into recent decades. We can see high water levels here, down to lower, and up again. And the trend line, interestingly enough, is almost zero. The lake has declined, according to this data, by about 1 centimeter over a year, i.e. pretty flat. So one of my concerns earlier this late last year and early this year was the rapid drop in lake levels. If we look at the right-hand side of this figure, we can see the lake level dropped. It's about 45 centimeters if we compared going back a few years, 2 or 3 years in Lake Superior. So a lot of decline in water levels. And I went back in time, and one of the places I saw a sharp water decline was the what had led up to the really low levels in 2007. We went from high water levels to down to here, record lows, record at that time, highs down to record lows. So this kind of pattern invites what's next. And we'll probably speculate about that in question and answers and our breakout sessions. Another component of Lake Superior is precipitation. And the lake levels are, that's the most important factor. There's other factors, but the amount of precipitation is a considerable factor on lake levels. Understandable, I think. This is a glimpse of the past. This, I had a lot to work to do with the flood in Thunder Bay in 2012. And one of the figures I presented to City Council and the public at that time was this, figure here of weather warnings that extend down. Here's Lake Superior here, and these weather warnings extend southwest from the lake down here. What is happening in this situation, I won't go into detail, is it taking water from the Gulf of Mexico, moisture, and transporting it up this corridor up to Lake Superior. And the result is that we had flooding situations in Thunder Bay, and other centers followed in that particular year of the flood, 2012. 3 weeks and a little bit later in Duluth, they had the highest rainfall amounts on their recorded history at that time. And I coined the term at this time, atmospheric rivers. Now, I wasn't the first one to dream this up. It was in common usage about the West Coast, the so-called Pineapple Express on the West Coast, when you have a corridor of moisture and lots of rainfall in BC and Washington State and so on. So, but I thought, oh, okay, we have something similar that originates from the Gulf of Mexico, and these atmospheric rivers in our region transport a lot of moisture up to Lake Superior. And the water level can change considerably. The Duluth flood resulted in a rise in lake levels of Lake Superior of 9 centimeters, one storm event. This is, I won't go into detail, but this is one of the things that we in the Great Lakes and Lake Superior area have to think about. The almost certainly will have increased precipitation, longer events, more rainfall over time. And back to the present, this is just a quick glance of lake levels over time. And you can, I'll just focus on this 2021 here. We have a change from summer high level waters, usually in August and September. And then we have decline to low water levels in the early spring. It's about 30 centimeters on average. And here the U.S. Army Corps of Engineers has done a projection for the next few months. It's a lot of range in there, but what they're basing some of that is on, we don't know what the next few months will bring for sure, but also there's a lot of doubt at the moment whether the Southern Oscillation will be La Nina continued or switch over to the El Nino phase of the oscillation. Now, it's amazing that something 10,000 kilometers away, warming or cooling of water in the Pacific Ocean can affect our water levels and other features in Lake Superior, but it seems to be one of the major factors that does that. And this slide will show you some of the relationships between air temperatures in Thunder Bay and the western part of the Lake Superior Basin with what's happening with El Niños and La Niñas in the Pacific Ocean. These above the line, we have red indicating El Nino, and you can see 1, 2, 3 major events and a number of minor ones. And below that, we have La Niñas depicted in blue below the line. So this is what happened in time, over time with winter temperatures in Thunder Bay. This event here, and here had temperatures way above normal for the winter season in Thunder Bay. And I'm counting December, January, and February as winter in this case. And the other effect is it's not as pronounced. This is looking at this year. El Nino resulted in 2 degrees, sorry, La Nina resulted in temperatures about 2 degrees below average. Yet last year, 2 winters ago, the temperature was above normal, about 2 degrees. So La Nina is not a great predictor of what the future will hold. El Ninos are, because they affect a few things: air temperature and ice coverage and water temperatures through the winter. I just wanted to squeeze that in because we don't know what happens next, which phase we go to, or even if we start at remain at some kind of neutral point. So many interrelated factors on Lake Superior. This figure tries to show how some of them are interconnected. I've hinted on some of these today: water levels, decreased ice cover, warming air temperatures and lake temperatures, and so on. And this talk today features a couple of things. The very major change in the overtime with the fall or overturn that was shown earlier. And then certainly changes in winter and summer stratification. And the time, one of the things that stood out in this investigation is how much more variability we have in the system. We have more precipitation variability. We have ice cover, as you saw, varies greatly. Also water levels and seasonal temperatures. So a big factor. Here's, I just heard about this the other day. It's not Lake Superior, but it's Cloud Lake, which is a few kilometers away from Lake Superior. Counting the last 12 months, the lake has been at its highest point now and its lowest point last year in the dry times in August and September. So I'll conclude with this slide here and get us into questions and answers. And my talking animals, you can't depend on them on the questions, but they have their comments. So could we move into Q&A?
Sure, yeah. Before we do that, well, thank you very much, Graham. I mean, that's to have someone that's watching the data and pulling it together year after year to show us the evidence of what we've been sort of talking about with the lake is really critical. And I'd like to open it up for Q&A. And so how we're going to do that is, you can pose a question in the chat. You can also put your hand up. There's a large number of people here. So there's an option of us breaking into groups if needed, but let's move towards asking some questions. But Graham, I just wanted to go over just some of the main points here that I captured anyways. We're obviously talking about a lake that's warming faster than the other Great Lakes. But not only that, you are noticing and others are noticing that not only are we reaching peak warming temperatures in the lake, but we're also experiencing the opposite. And so not only is the lake warming over time, but it's also affected by a lot of seasonal variability, and that affects our perception of not just the ramifications, but the implications of warming. There is a balance going on. You specifically talked about within that that this rise in temperature we can see happening in the fall, and I can attest to, seeing a fall where we're having severe rainstorms and flooding instead of snowfall like we used to have in the past. You focused in on that 4 degrees Celsius, which is a key temperature for the lake to stratify. So that creates stability in the lake. It's very different in southern lakes, that stratification. And it's this 4 degrees Celsius stratification that's being affected by this changing temperature. So it's affecting overturn. The overturn is happening later with this fall time warning, and perhaps a later spring. I mean, we're noticing perhaps a later spring or a return to the spring of decades ago. And then you went into the dynamics. Obviously, it affects ice cover. This then affects water levels and the influence of storms affecting water levels now, because we're having more severe one-day rain events or more heavy summer rains. And then, of course, the El Nino La Nina factor that then oscillates on almost a decadal scale. And then further within, this now has ramifications for oxygen levels, nutrients, the anoxic zone, or the oxygenated zone of the lake, and the ability for fish, cold water fish, to exist. And then you did also talk about how, the changes in the bays. We might be having ice in the bays, but it's the open water that we're seeing less ice. And so now you have this variability within the geography of the lake itself. So, does that sound like, an accurate overall summary of some of these main mechanics?
I think that's a great summary, Rob.
And before I open it to questions, if I could just ask a question to start, can you comment on how this is different from southern lakes? From my perspective, Lake Superior is very unique. It's a headwaters. It has a longer residence time. It's very much colder. Does the implications of what you're talking about suggest that Lake Superior might look more like one of the southern Great Lakes, and what does that mean?
Maybe eventually. There's a fair amount of talk about what happens when Lake Ontario and Erie start missing the fall overturn. So I think it'll happen earlier, when we have occasional missing of the fall overturn. It'll take longer in Lake Superior because what you just mentioned, it's a more northerly lake, and the volume is much more than the other lakes. So yeah, I think it's a concern, and one of the features of some of the things talked about today, including the overturn, is that the warmer it gets, the more vulnerable it is to invasive species. So that's my take on it. That ideally, we would have more regulation of carbon going into the atmosphere. I don't think we can influence that so much in this regional level, but that's one of the things to think about.
Great, yeah. So the southern lakes obviously having one overturn more versus the two. And again, just for people, that stratification creates layering, creates stability, but then the overturn allows for mixing of temperature, and that has ramifications, positive and negative. Okay, well, I want to open it up to questions with the large group right now. Again, please, put questions in the chat if you feel like that's more comfortable for you, and we're really going to try to balance that. But I'll be looking for people to raise their hand, which can be done in the, I believe, the reactions at the bottom of your page. You just put your hand up, and then I'll try to pick you and go back and forth with the chat. And keep in mind, any questions related to what this means, what you're observing, what you're seeing. This is open to, more than just, what we're seeing from the data, but what the ramifications are and our intuitive knowing around this subject. So I'll open it up to just any sort of basic questions to start us off. And Rachel, if you can see in the chat, if you see any questions there, just interrupt me and bring them on in.
Yeah, great. Lindsay raised her hand, and then we've got 2 questions in the chat. So maybe start with Lindsay and we'll go from there.
Okay.
Great. Thanks, Graham. Thanks so much for your talk. Always learn so much from you. And thank you so much for your work in our community. You do so many great things here. So my question is actually about knowledge translation and science communication, which you also have, a lot of expertise in. And this is something that I hope to learn a little bit about in my work, which I sometimes struggle with how to convey about both variability and overall trends. So my specific question for you, Graham, is what have you learned over the years in thinking about these data in particular, but also your work over the years about how to convey this variability and the overall trends to sort of a general population and in particular, perhaps decision makers?
Yeah, it's a tough process because some people might say, hey, it was really cold in January and February and March. That cancels everything about climate change and changes on the Great Lakes. And of course, that's not true because we have to look at the trends. But it makes it more complicated. We don't start from zero every time we have a cold day. And a cold season on Lake Superior. So I don't have a great answer to how we solve that. I think we have to say that, yes, but let's look at what's happening over 100 years or how it's changed in the last decade or two. I think that's one way we do it. How about other people? Do they have brilliant suggestions how we accomplish this?
Well, I like what you're doing, Graham, which is, we regularly hear of modeled predictions and dynamics. And, we often speak about climate change based on those models but we're in a world that I think individuals want to see the data. And so going back to, that more basic work, I don't mean basic, but more, realistic work of looking at records, comparing records to ensure that we are, seeing in the data what we're seeing in our observations from year to year is critical. And I think we've moved away from that because I think climate change science has always been sort of, let's wait till there's more science to confirm. And we've done that for 20 years. So, I like this concept of the local person looking at the data so they can see it themselves. And in your case, this is data sets that you've been collecting for decades. So it's not like it's something you just pulled down last year. You've got a record over time before, people were even talking about climate change on Superior. So that science really does connect experts with local observations. I did have a couple questions I'm seeing here about, thanking you for the talk. Has there been any work on collaborations to draw correlations between the variability in the water's temperature or timing of overturn and stratification? And then furthermore, linking that with biological indicators. And so we've sort of talked about this, Graham, because the presentations we've given in our undergrad classes sort of stop at, the data that shows warming on average, but doesn't really go into enough data to show variability. It doesn't have enough data to show that there's a direct biological component. Your opinions, where are we at in the data? Are we still just talking about averages in temperatures, or is there data to show that this variability is also happening and observable in the record?
Well, I'm tempted to, could I skip along to another slide I have down below?
Definitely.
Is that possible? I hope it's possible.
Yep, you're still on the screen there. So just you can move through your presentation back.
Okay, here's our an example of, and it won't happen for a while in Lake Superior, but here's an example of over time in other lakes and eventually in bays in Lake Superior, what happens in the future for some marine species. So at the moment, our fish down here is in cold water. It wants to be there. And this is the position of the thermocline in the year 2000. if we go into the future, and I'm stressing that takes longer in Lake Superior, but other lakes, what happens if the layer of water on top becomes warmer and warmer? It means our fish here is more and more confined. So that's just a quick snapshot of what is possible in the future. One little example. I mentioned invasive species, that's another one too. I'd like to add a little bit to the previous question that you were exploring, Rob, and that is, how do we expand the number, how much, we don't have enough observations. I think there should be people, and there are right around the lake, who have weather stations now. I think it would be a great idea for Environment Canada and on the US side to start being able to utilize these observations. And that would have two effects. One would be more information available, but also I think there would be word of mouth. If you have different people that people are acquainted with, and they have with little weather stations, and they're watching what happens with the weather, and different people would be more aware of what's going on in Lake Superior and other situations too.
Yeah, and you can really see that in that, sort of in that diagram, in the sense of those changes to ecosystems. Some of the other things too, just to add on to this diagram that we're seeing is, the wetland environment and the submergent wetlands that we have that, with lake levels sometimes are dry and sometimes are quite wet wetlands, and that creates diversity and so forth. So, some of the changes you're talking about, aren't just related to the food web for fish communities, but certainly the wetland habitat, waterfowl, bugs, birds, animals, all the things that live in wetlands may very well have variability from, more extreme changes in water level affecting that wetland environment. So I just want to add that, that there's much more understanding of how these changes affect larger ecosystem dynamics, but the ability to publish and produce data that shows those longer term diverse changes to ecosystems is harder to prove through data sets. But certainly, changes in wetlands, changes in shoreline from lake levels are going to have that subsequent effect. Other questions, whether it's people raising their hands or in the data set? I've got one here from Reg Nelson asking, is the depth of the thermocline collected as a data set at various stations? So in other words, do we have the thermocline collected, substantially with data, or is this sort of smaller base stations that we're inferring from?
Yeah, I think there's very few buoys and locations where they do measure this. That's one of my concerns, that we don't have enough installed research instruments. And one of them I'd like to see is evaporation, because one of the obvious components of Lake Superior and the surrounding basin is how much moisture is going directly into the air. As an example, in Australia, they have dozens and dozens of weather stations that routinely measure evaporation. It's certainly critical in Canada on the prairies and around anywhere really, but it's not done because it's not very convenient. And it's really not that expensive, but it's not done on a routine basis. So the answer is, I think measuring what's happening at depth in the lake is really critical, and there's not enough of it.
Right. I see a hand here from Frank Wilson. Frank, are you there? Turn off mute and ask Graham.
Yes, I am. Big thanks to Graham. Always interesting to hear you and see your data sets. I'm wondering what role the wind plays in terms of the lake and its levels and its temperature, obviously wind direction, wind velocity, and how this has been changing as all our climates have been changing.
Thanks, Frank. Yeah, really important component of all of this, because wind affects breakup of ice, evaporation, and so on. And it's thought, again, I don't think we have enough data to know this for certain, but a lot of people say and speculate that the winds on Lake Superior or onshore are stronger than they used to be. I think that's the case, but it's difficult to measure or prove because we don't have enough monitoring of that. So that's a difficulty. So back to the more research is needed. I think that's certainly a critical one because, as you've alluded to, that's pretty important in this discussion.
And we did have a comment here. I think it's important. Toby Breathwaite saying he believes the thermocline is regularly sampled and determined at the time of the fisheries assessment. So there are, there's an example where during fisheries work, the thermocline is sampled. So that's a reliable source of data in addition to the weather stations, or sorry, the stations that are out on Lake Superior. But certainly, perhaps a comprehensive full season thermocline analysis beyond fisheries. It might be something in the long run to get that larger lake picture, I suppose, or cross-border particularly. So thank you for that, Toby, and you can always chime in if I mischaracterized your intention there. Charles Levco has his hand up. Charles, are there and unmuted?
Yeah, I am. Yeah, I just wanted to just start, Graham. Thank you so much for that extremely insightful presentation. It's really, really fabulous to hear, to see some of the data you're talking through, and just to hear some of those details. So thank you for that. I wanted to ask a little bit of so you've talked about, and some of the other questions have been around fish and fisheries, and I'm really interested in the way that some of what you've been talking about affects the fisheries, could affect the fisheries, or does affect the fisheries and fish populations, specifically in relation to kind of the human engagement with the lake and with fisheries. But so if you want to say anything more about that, I'd love to hear anything you have to say. But the other question I guess I was going to ask as a follow-up to that is the implications of some of what you've been talking about for regulation, for policies, for conservation efforts, in respect to fisheries on Lake Superior. And I mean, obviously we're in the Canadian side, but there's a lot going on the American side too, that, this is all, I have no doubt many of the results would be the same over there because we're on the same lake. So anyways, anything you could say again about the fisheries, fishing, and maybe some implications for policy, regulation, and conservation efforts.
Thanks, Charles. My knowledge of how it affects the fishery and other aspects is pretty limited. I showed my convenient little diagram here, and that's one of the aspects I'm sort of makes sense to me. I think over time, I think probably most people, including you, know about this, that the rumor is, or the discussion is, that as we have warmer and warmer water, and including bays in Lake Superior in this, we'll have more fish species, and they'll be with those fish with other species that are now normal cold water species. That's one aspect. That's probably as best I can say on that, because I'm a weather guy, not a fish guy as such.
Yeah, and I do see people on the call that have great knowledge about that could either type, speak up or add to the chat. But in addition to the anoxic zone that you've described, that oxygen level, available to fish in the lake decreasing. You've got the ability for nutrients and algae and different phytoplankton to develop, different types of interferences with the food chain, as well as blocking sunlight into the lake from different types of surface algae, if that comes from temperature increase. As you had mentioned, Graham, you've got invasive species that are now have a temperature zone that they might be able to habitate and then more aggressively affect the predator-prey relationship. You have growth rates in fish that are affected by temperature and feeding in the food chain. So, I really think we haven't highlighted in society in general, these feedback loops that are just as critical, especially to our way of life and to connection to us. And I think that's really important. Graham, I have a comment here from Jason Freeburn that, just to see if you can agree with it, because I know that you've not only done this work, but you've taught courses where you've looked at, the IPCC, the International Panel for Climate Change, the COP22. You've always followed summits and climate change, carbon reduction summits and invited speakers in your class. But what Jason's saying is that, he's agreeing greater variability over time, not just warming, more common extremes seems to be consistent with temperature, ice cover levels. And so he's basically saying, what you're showing seems consistent or even more severe than the climate predictions and the climate models we've been using to date. Would you agree with that we're seeing what those models from 10 or 20 years ago were predicting, or were those over or underestimates?
Well, I'm recalling Adam Cornwell remarked the other day something about too bad we were right when people back in the 1980s and the first couple of decades of this century, people have been running up the warning flags, and as you mentioned, we can't know for sure till we actually have the numbers of 2030 to know whether we're right about this. But the trends are so pronounced that as a policy maker, I think it's essential, and public too, to at least hedge our bets and get prepared for the worst case scenario predicted. And we have to do that in rainfalls. Otherwise, we're going to lose infrastructure all the time, and so on. So yes, I agree with Jason that I think things are typically, we've seen a situation where the prediction comes through and it's even worse than was anticipated 10 years ago, 20 years ago, 30 years ago. Think about what happened in BC. If somebody had said, dared to say, we'll reach a top temperature of 50 degrees in British Columbia, that would have been dismissed, I think. But it happened, and we're starting to have chains of events. We have heat, forest fires, floods, and that's on land. But I think we have to also think about the scenarios of the Great Lakes too, and start getting ready for more severe scenarios.
Agreed. Yeah. Couple more questions, and I'm going to save Paul Berger's question for last there, so I'm not going to forget it. I'm going to save it. Aaron Hudson, with the increase in algae complaints, sightings, could this algae data also be collected and useful in some way? And I'll let you answer that, Graham, but we are just beginning, I believe, on Lake Superior to really start to explore algae blooms. And on the US side, there's been far more occurrences, warmer water, shallower watershed, perhaps more agriculture and nutrient loading, or rivers contributing. And on the Canadian side, we do see it in the news in the basin itself, but no sort of confirmed publications on the algae bloom problem on the north shore of Superior. But Graham, that being said, would you expect from the data you're looking at and what you know about algae blooms, that your data supports the idea that we should be, looking and monitoring and much more aware of algae blooms from the past, where we just maybe didn't imagine algae blooms being a reality on Superior?
I think I'm right thinking if we go back 20, 30 years ago, this is a non-event problem in Lake Superior, even in the United States. Isn't that true?
Certainly, there's occurrences on the U.S. side for sure. Yeah,
it certainly is now, and it's more and more. So, I think we have to take our cues from that. Especially if we're on the same lake, we have to assume that the warming trends that are apparent across the lake eventually. We probably have a little extra time compared to the United States, but I think it's a problem that we have to prepare for. And for sure, we have to be measuring things and connecting what is the water temperature and the algae blooms, how interconnected is this?
Yeah, and certainly, on the Canadian side, the reporting of algae blooms is so critical, because that is the key mechanism for investigating and documenting. So, the provincial government receives reports when you see an algae bloom, and that they'll come investigate, which is a critical process for us to learn more about the impact of algae blooms. A couple more here. I'm just paying attention to the time here. Here's an interesting one from Tim Hollinger, talking about just fluctuations in water levels affecting other processes within the Great Lakes. And there's a publication here that might give you a little bit of dynamics about that idea, but I think it's more of a theoretical question. So, I'm just thinking about residence time. Lake Superior has about a 200-year residence time versus much shorter times, 20 years or 30 years in the southern lakes, because they mix with the St. Lawrence much more. So you've got this aspect of residence time in the lake that's now heating. You've got fluctuation in water levels. That the control works at St. Mary's affect water levels. The question is, would fluctuation in water levels, or are the water levels on Lake Superior, do you think, have potentially an effect on the mechanics of the lakes downstream?
I would presume so. And I'm thinking, I mentioned the rise of Lake Superior. I'm presuming, and I haven't researched this, but I'm thinking that kind of heavy rain event, and there's more heavy rain events going directly into the lake, that would change the mechanics of the lake. You would have all of this new weight on top of the lake. So that would change what is happening. And I don't know this, but I presume that the connected to this chain of thought, the residency time, I think it's 193 years or something. I wonder how much that has changed over the last 3 decades, and should it be monitored into the future? I think it should be.
Mm-hmm. Yeah, and we know that there are some strict rules on how the IJC, or how we regulate waters out of St. Mary's from Lake Superior, usually for shipping purposes. But looking into the future, Georgian Bay water levels are low. Would that affect management and potentially regulating Lake Superior to support downstream lakes, and so as we move into a variable lake, or a lake that's undergoing change, there's also a management implication on how we regulate water levels, and perhaps our current regulation is based on past climate averages or lake level averages versus what potentially your data is suggesting into the future. So yeah, you've had experience with IJC levels that, and how that's run. Any comment on that, and how, those rules may provide an opportunity or a barrier to adapting to changes in the lake?
Well, I'm thinking it probably is going to lead to conflicts because you mentioned Georgian Bay and so on. And part of my thinking was when I noticed a drop of 45 centimeters in lake levels, that's gigantic. And it means that there's all sorts of implied problems with if you have a lot of fluctuation, there's problems with shipping, there's location of people's docks, and also and in the past, we've already run into this a little bit. If there's too much water, so-called in Lake Superior, then more is released downstream. But often, if there's high water downstream, then they don't want any more water. So there's limits to regulation and release of water at Sault Ste. Marie. And I expect in the future that we're going to have more conflicts about that, because I put in this I'm making up a story. I put in an expensive dock system, and you people are ruining my leisure time with because my dock is out of water or submerged in the water. I think there'll be more problems like that in the future.
Okay, I'm going to move to our final question here from Paul for Graham. Graham, Paul would like to propose that we pick a later fall overturn date and link it to replacing the Prime Minister. If the overturn happens after that date, the PM must step down and be replaced. What do you think?
I like it, and I think some humor. Oh, you weren't being funny, was you? But yes, I think there. A couple of people mentioned, what can we do about this? I think it's important for groups of people, universities, other interests, to be writing to their federal and provincial reps on this, and maybe being much more assertive than in the past. And maybe we can incorporate that. Are you willing to solve the problem, or if this happens, you're out of office? Maybe we can incorporate that too.
Yeah, and it is a sort of an interesting comment on the politicization of climate change and the lake. And maybe if I can conclude with sort of commenting about not only the importance of the data collection and constantly having observing our data, especially if we're going to not rely on experts so much, then not only do we need to get out and get this data, and what you've shown me, Graham, over the years is that this data is accessible. It takes a little bit of patience to learn that process, but people can, given the scientific method, test these things out for themselves, pull data down from these national databases and have a look at trends and intuitions that they have. But what you've presented too sort of signifies that changes on the lake aren't just about heat and cold and opportunities and barriers. There are tremendous values attached to this: fisheries values, cottagers values, the more existential values for the lake, or a reflection on how we're adapting to changes. And so, rather than just waiting around for the experts to tell us what to do, we're involved in a very complex system that has far more feedback loops than just what the data shows. And that means, understanding those changes, adapting those changes, and including more values in what those changes mean is really, as a society, perhaps that might make us adapt and might bring the local person into the discussion more than just the climatologists and so forth. So, I really wanted to thank you for, your focus on the science, your focus on the principles of climatology, but your devotion to sending that message out, connecting with people, explaining it like an every person, and looking at the people you talk to as an equal knowledge holder, whether they have that same background or not. So thank you very much, Graham. I really do appreciate the work that you do, not just, for the Academy, but at that local level, day in and day out, and what you've presented. And with that, if there are more questions or more dialogue, you can certainly reach out to Graham or myself. I can see that Rachel is putting in emails, so I'm sure Graham or I can be emailed directly, whether it's about Graham's presentation or in the long run, more content or discussion around these more complex issues that involve local people, scientists, and managers equally. So thanks for the attendance, everyone. I hope that provided you with some insight, and please don't hesitate to contact Graham or I.
For sure.
Thanks, Graham.
Thanks, Graham. Thanks, Rob. So great, folks. Contact information there if you'd like to connect with the Lake Superior Living Labs Network directly. That's our email and website. Yeah, otherwise the recording of this session will be made available. I will email it to everyone who registered, and feel free to distribute it at that point as you see fit. Otherwise, we hope you have a great day and have a few minutes here before your next meeting.
Thank you all.